And now on to our feature presentation. Don, our past president, former president, former secretary, basically the individual that kept us on life support through COVID, kept us going and secured this venue and a number of other things. Recently, last fall, did a 5-week luthier course at Blackwood Guitar Making School. And this gentleman that runs this school, what's Tom's last name?
It's Ted.
Ted
Brown.
Ted Brown. Ted Brown has been in the woodworking community for quite some time and formerly owned a school out in Helmont.
So if you guys knew Rosewood Studios, he started Rosewood Studios.
So it was 5 weeks, and after the 5 weeks, you ended up with something that made sound.
It did.
And basically, I'm going to turn it over to you, Don. And
Did you bring it in?
Yeah.
Oh, okay.
Don, is that 25 days or 5 weekend sessions, or what was it?
I'll get into that. Don't get ahead of me. Roger.
thank you, Don.
So this is going to be kind of a compressed, this was 5 weeks, 6 days a week, from 9 o'clock in the morning till sometimes I wouldn't get out of there till after 7 at night. That's how long it really took to do it properly. And you know, a lot of there was boo-boos made, of course. But the beauty of working with a really good luthier is he shows you how to fix the boo-boos. So that's the best part. So yeah, this is down near Mallorytown. So it was, for me, about 100 clicks each way. So I drove down and back every day. So I put lots of miles on my I-5. That's okay. It wasn't costing me a whole lot. But yeah, it was a really, really good experience. Ted's a really good teacher. So that's the sign up front, so you can't miss it.
Actually, a sign on the highway too.
Yeah, there is a sign on the highway. So there's a story behind that sign on the highway. So my wife and I were driving down to, I think it was either Stratford or Toronto, I can't remember. And so we were on the 401, and my wife said, "Wait a minute, there's a guitar making school." She kind of filed that away. And last April, I had a round number birthday. I turned 70. And so for my birthday, she said, "Go take the course." Oh, okay. So that's how this all started.
Was that their birthday? She wanted to get rid of me?
I think she wanted to get rid of me for 5 weeks, as Jacques knows. So that's Ted. He, not only does he teach, he actually builds guitars. His guitars sell for, his guitars probably start at about $7,000 and go up from there. So for custom guitars, that's quite reasonable. When you look at the amount of time that he puts into each one of these, they're worth $7,000. That's the shop dog. That's Bailey. That dog would open the door and walk in the shop. And then if there was any food around, like your lunch, he'd come back. Pretty smart dog. He also ate Ted's glasses at one point. So, choosing the wood. When you first get to the guitar school, the first thing you do, you walk in the shop, you introduce yourself. And then you have to decide what guitar you're going to build, because there's a number of different models you can build. And then once you've decided what model you want, then it's what wood are you going to use. And you don't just go to the lumber pile and pull out lumber to build a guitar. Okay? The top is basically split wood along grain. You can't have any. It's basic. It's all quarter sawn. Everything's quarter sawn. Okay? The back side's top quarter sawn. A couple of reasons for that. But not every type of wood is appropriate for use in an instrument. The wood has to sound right. So the first thing you do is he lays out all these tops and sides and backs, and the sides not so important. They just basically hold the back away from the top. But the back is a sound producing element, and the top is a sound producing element. But you have to understand how that wood is going to react to vibrations. So basically, you pick the piece of wood up. I think the next one shows it. So you can see one of my colleagues, basically he's got the top of his guitar, or at least one half of the top of his guitar. They're all book matched. And you hold it like this purposely, and you tap it. And you're listening for two things. You're listening for sustain, and you're listening for the note. It should ring like a bell. If it goes thud, 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 not good guitar wood. If it goes ding, not good guitar wood. What you want is ding, like that. So that's where you start. What I chose was a piece of torrefied Sitka, and it rang like a bell. It was more expensive than he decided to pay a little extra for it, but it literally rings like a bell.
So Don, where do you get that wood?
He buys it all over the world.
Oh, yeah?
He buys a lot from, you can get it, there's a couple of places, a number of places in Canada where you can get the wood. There's a place in Eastern Townships that you can get it. Not every type, but I'm actually going to be going there in probably a month or so, because my girls now want some guitars, so guess what?
Does he rive it himself?
Hmm?
Does he rive it himself?
No, it comes as match sets.
Okay, so somebody
So,
else is.
so
removing it.
these woods sell anywhere from, like for a back and side set, from let's say $50, up to, the last time I priced out wood from the tree, it was $10,000 just for the back and sides. But it's a different kind of wood, right? It's full. So for the back and sides, I chose a Ziracote, which is a wood from South America, Mexico, northern part of South America. It's very much like a rosewood, but it's got its own characteristics. I didn't realize how difficult it was going to be to bend, but that's another story. But you can see the price for the back and sides was $500. Just and it's like this thick.
Is that for the pair or individual?
No, for the pair. Well, for the back and the sides,
Okay.
for the set, because that all comes as a set, right? The next thing you have to decide is, okay, what guitar are you going to build? Are you going to build a small guitar? Are you going to build a big guitar? Are you going to build a jumbo? Are you going to build a dreadnought? What are you going to build? So I chose what Ted calls this small jumbo. And it's really meant for more fingerstyle people, okay? Because it sits on your lap properly and that type of thing. But that you use that form until basically the box is done.
Do you make this form, or is
No,
this?
he had the form made. So joint in the back and the top. So this is where you start. So you're going to see a bunch of different guitars being made here. I took pictures of stuff as I went along, but it's pretty hard to take pictures of when I'm jointing it, like while I'm joining it, I'm busy, right? So what you do is you start by jointing the top and the back. And basically what you do is, it's a very small cut. What he's doing on the left-hand side there is he's just straightening up that side to make it easier to actually joint it. But you joint one side with the face pointing out, and you joint the other side with the face pointing in, okay? So that when you point the two things together, they fit, okay? And I think most of the guys actually literally went over the jointer once, put them together, you hold it up for the light, and nothing comes through.
Do you follow up the rotary jointer with a flame?
Didn't have to. Didn't have to. It was dead on.
Yeah, I know, but you still get the sparks.
No. No, it was absolutely dead on. You don't, like when you put it through, you don't go zoom like that.
Yeah.
You go through
You
slow.
go through
okay?
slow, yeah.
So, yeah. And don't forget, it's this thick, right? So when you put them together, there's a gazillion different ways that you can actually put those bookmap pieces together. But Ted, he's a practical guy, okay? And he's come up with a super simple way. You don't have to build any friggin' jigs. Nothing. You see the tape? Watch what he's gonna do.
Enough? I said, yeah. I said, the joint is good. Right, you shouldn't have to clamp the shit out of something that's two pieces that fit together. You know, well, without glue on it. It was done well in California, there was lots of Phillips smoking out there.
So what he's done there is he uses tape that they use in the automotive industry. You know, when they're taping around kind of weird shapes, okay? It's very stretchy tape. So what he does is he just puts the two pieces, you put the glue on, put the two pieces together in a flat surface. You hold one side down and pull, and there's enough pressure just from the tape to hold that thing together. You leave it, because it's a critical joint, you leave it for a day. And it's perfect, comes out perfect every time.
What kind of glue are you using?
It was Type Bond 1,
Oh, okay.
not 3-1.
Is there a reason for that?
Yeah, because if you make a boo-boo, with Type Bond 1, you can use a heat gun and take it apart. With Type Bond 3, you cannot. What he was using was hide glue on his guitar.
Very good.
Okay, which I gotta tell you is a pain in the ass. It's really difficult to use, okay? Like the working time for hide glue is like a minute, okay? Whereas this stuff you have a bit of, you know, he wasn't gonna make his students do hide glue, so, which I was very thankful for.
But on the flip side, hide glue is really easy to disassemble.
You could do it with this as well.
Yeah.
You can just use a heat gun and it comes right apart. In fact, one of the guys, when he glued his, I think the top on, screwed it up, and just used the heat gun, went all the way around, popped the top off, did the adjustment, put it back on again, glued it, we're done. Now, that was a day's work, but that's why it takes 5 weeks.
Enough? I said, yeah.
So, when I got the back done, glued together, that's what it looked like,
Well, that's beautiful.
okay? That was my glue. So, sides. How do you get the shape? You can see here. This part here is the and the top part here is the rig that they actually use for bedding the sides. This is the form, and every guitar has a different form. So that form actually matches the form that I showed you, the outside form. So this is the inside form to get the sides to the right shape. Okay. And the way that works is, well, I'll show you. So here's basically a whole side
Okay,
bed.
so wrap that baby up like a Christmas present.
So before he did this, they actually, he took the sides and you spray them with water, both sides, get them nice and wet, okay? But what I want to show you here is, I don't know if you can see the pointer. Can everybody see that? Okay. So there's 2 sheets of spring steel underneath. There's a heating pad, okay, that goes to 300 degrees Fahrenheit, or Fahrenheit as I like to call it. There's your side, and there's another piece of spring steel that goes on top. And then on the machine, on the bending thing, there's another small piece of spring steel as well.
Some paper clamps.
So the other thing you notice, do you see the 2 black lines? There's a black line here, there's a black line there. See those? They actually, they're there on purpose, and he'll explain it in the next part of the video.
Just, the form I see in the background, I assume it's hollow just to avoid wasting material.
Yeah.
Okay.
You don't need it any more than that because you get 2 pieces of sheet steel, of
Right,
spring
yeah.
steel underneath it, right? So it's not really a problem. It doesn't telegraph through.
Okay.
I have seen them where they're solid, but that's the way he makes them. So you make this sandwich. See the other piece of spring steel?
That's it there.
So what he's doing here, the little mark that was in the center, he's aligning that up with a mark that's on the form. Okay? And so long as you got the distance between that mark and the end mark, the big line on the end, when you bend it, it's going to be over the end, so you're going to have to cut some off. It's better than being too short, because now you're screwed. Right?
How long has it been heated before you get to this step?
How long? He hasn't heated yet.
Oh, it hasn't heated.
No, he has not heated yet. He's just lining everything up.
If you don't get that right, you're gonna run out of wood at one end of your
Which is what he said.
bed. Yeah, sure. Because it could be like this, too long here, too short here, then it's ruined. Okay, so that's why we have those black marks. Now, this goes in between there, get it underneath.
So what he's putting in there now is a thermistor. It's a probe,
Underneath the
so that we know what temperature that wood's at.
So that's the wood. Okay, well halfway now, we're just gonna crank it down so it just plates down a bit. So now, we put on the end rollers, other side up, we got one. And this pin goes through the hole.
Pretty simple
So
design.
that's normal. That went very easily because it's, crank down so it stops, don't mush it when it gets to the bottom.
So at this point, he's heated it up. So that wood, you start bending when the wood is at 265 degrees Fahrenheit, okay? And then you let it heat up and it stays at about 300 degrees Fahrenheit for the length of time.
Are you essentially steam bending?
Yes,
I mean,
exactly.
you've got it all
It's
totally enclosed,
That's exactly what you're doing.
it's all wet, you're
Yep.
heating it up,
Yep, yep,
steam bend, cool.
yep.
Stop when it stops. Well, if you mush it, you'll break it, right?
And that it happened. You have to be really careful doing this.
A little bit more. There.
As you're bending it, you're listening for a crack.
Okay, now bend your ends.
And of course, different woods have different colors.
Exactly.
Take your paper clamps off at this point.
Quite a fancy
Have them up the other one.
bending machine.
Yeah, it's pretty simple. But basically, it's just a heating element with a pin.
Okay, now do the other one. Okay, take the clips off. If you don't have the clips on, then the heater isn't against the wood. And it's just sitting there in separate pieces and nothing gets heated.
So you're on the timer from here.
15 minutes?
15 minutes, you're done. Okay? So you do that for each side, okay? You got to keep in mind, you got to match set, okay? So one set's got to go in like this, the other set's got to go in the other way, right? And he's got a way to actually idiot-proof that, okay?
Good.
Okay? On top of that, you also have to bend, because what he does, and I really like this method, is he laminates the sides. So you have, in case of mine, I have the zero cote on the outside. On the inside, it's cherry, okay? But very thin, all right? So basically what that does, I don't know if you ever looked inside of a guitar, you see all the ribs inside the guitar? You don't need that. The sides are not an acoustic element. The sides basically just hold the top and the bottom away from each other. It's basically just an air pump inside a guitar. Okay?
Sorry, the two clamps on each end.
Yep.
How much tension and how is the tension provided? Like I see there's like rollers.
The springs.
They're on-
Inside those springs, the roller things.
Yeah.
There's a couple of spring things
Yeah,
that
spring
are
things.
adjustable.
One of
okay?
those technical terms.
And you don't need, yeah, the technical term is spring in the thing.
Yeah,
You don't need a tremendous amount of pressure
yeah.
because you're bending a piece of wood that's maybe 2 millimeters thick.
Oh, is that all it is?
That's all it is. Okay, it's very thin. It's like this thick. Okay. Then the sides, basically, you take them down a bit, but not much.
Yeah.
The top and the bottom is a different thing. Top and the back are different kind.
But the laminate of the two, it's not glued.
Yeah, it's blue.
Oh, you glue it first?
Yeah, don't get ahead of me. You're getting ahead of me now.
We're taking the short course.
Yeah.
Week one.
Okay, so you can see what he's got in his hand down there is the back, the sides that you actually see. The other piece, the lighter piece off to the left-hand side, that's the cherry that actually fits inside. And this is how he does it.
That's reasonable amount. I know, I won't need that again, I'm just giving you a hard time. Just park it somewhere.
Ted was
So
actually
now,
very
so it
patient.
doesn't move around, because you know, glue causes everything to move. What I do is I hit it. This is holding pretty well. Sometimes they're a slightly different shape, right? One to the other, but this is holding pretty well.
And the reason for laminating
And that's just gonna keep things from smushing on you.
And so you don't need the ribs. You don't need the ribs on the inside.
Yeah, and the zero coating is not.
Okay, so it's unlikely this is gonna move on you.
Sorry,
So this is basically so that when you clamp it up, it's not going to slide all over.
Okay, so then
So this is a structural thing, not an acoustic thing.
Correct.
So the cherry veneer isn't going to change the sound.
Correct.
So the cherry is done the same way
That's reasonable.
as the exterior?
So that's what it looks like. So he's actually got a separate form for actually doing the final glue up of the sides, okay? So now you have a side, and you have the same thing for the other side. So now you have the two sides actually built up of two pieces each laminated together, okay? And then you clamp the lid in. Yep.
I assume it doesn't matter that it's cherry for a species, it's just that cherry is a cheap domestic, decently strength.
Yeah, but it's gonna be quarter sawn, right? So it's easier to get quarter sawn cherry than quarter sawn maple and stuff.
Okay, yeah, but it's a pragmatic choice, it's not cherry.
Yeah, I mean, you
because
could use something else, but he just finds he gets good results with cherry, so.
Okay.
Yeah. How's the cherry formed? The same way as the?
Same way, exactly the same way. It's about the same thickness,
Yeah.
maybe a little less. And then basically, I think he actually makes those parts himself.
Mhm.
He just cuts them on a bandsaw and runs them through his drum sander, and there you go. So the next thing you gotta do is, if you look at a guitar, the top and the back are not flat. They're actually domed, okay? And the back is actually cut. It's a little thinner towards the neck than it is at the other end. So what he's doing here is he's actually trimming that, doing the first rough trim on it, okay?
What's the variance front to back?
It's about a half an inch, 3/4 of an inch, something like that. Yeah, yeah.
And how do you map that out?
Carefully.
Honest to God, this guy's amazing, okay? Like, he was always teasing me because I'm from the engineering world. I measure stuff, okay?
Yeah.
He would go, this has got to be 3/8 of an inch. And I'd measure it as 3/8 of an inch, okay? I know. This is a design that Ted came up with, and as a structural engineer, good design, okay? So what that block is on the left, that's actually the block that actually connects the neck to the body, okay? But the beauty of that is you have a lot of top surface gluing area and you have a lot of bottom surface gluing area, which is really, really what you want, because that neck can do this, right? So that's a really, really good design. The trench that's run through it is for the truss rod. Okay? The adjustment for the inside the neck. And a lot of it is, like what he's doing there is he's sanding it to fit the curvature of his guitar. Okay, I think that was for his guitar. There was actually 6 guitars on the go at the same time in the shop. He's actually got 6 benches for students and then his bench. It was 5 students.
That block is made up of alternating, like plywood, alternating.
And he makes that
layers?
up. Okay, it's done with Spanish cedar. Stinks to great hell. It stinks, it really stinks. Driving home, all you can smell it. When you're sanding this stuff, it's really, you really smell it.
Like hamster cage.
Yeah, so as I'm driving home, all I could smell was this friggin' cedar. What's that?
That's a lovely shop.
Yeah. Yeah, when you're in it all day, not so much.
Is he making a guitar?
He's making a guitar, yep.
Okay.
So there was 6 guitars on the go, all at the same time. Okay? So I should have taken pictures, because he's got 2 areas to his shop. He's got the bench area, okay? And the only power tool he has in there is a small table saw, okay? That most of the time is being used just for storing stuff, okay? And then all of his major power tools are in the back room, okay? The bandsaw, he makes great use of the bandsaw. He does almost nothing with the table saw, except for, I'll get to it. He's got an amazing jointer. He's got his sanding equipment back there. He's got a drum sander this wide, okay? So yeah, he's quite well equipped. Plus he has a sanding setup for doming the back, for doming the boxes, okay? Most people do it by hand, but he's actually built this rig where all you gotta do is hold the bloody thing in the right spot and it domes it for you. Okay, but you're there for 45 minutes. So, you've got your sides done, and hopefully you've bent them the right way, okay? And if you think that's a lot of clamps, that's only half of them. You flip it over and you put more clamps on, okay? I'm not kidding. But you can actually
How much does that weigh
see,
when you go to flip it over?
it weighs a ton.
I know, I can
Yeah,
imagine.
and you gotta be careful, right? Because, you know,
That's why you have the students to help you lift.
exactly. So you can see here, that's the neck block, and that's the tail block. See it? So that's what actually holds everything in place. Once you get that neck block and tail block glued in, it holds everything in the right spot. Yep.
Why don't you use the jig that you use to bend the wood to laminate the cherry afterwards?
Because I suppose you could, but I guess he finds it easier, especially for clamping. If you have just one section, it's much easier to clamp it.
I just answered my own question. Bending, when you laminate it, you gotta clamp all the way along when you try to laminate the cherry.
Yeah.
So that jig probably won't do it.
No, it won't do it. You really have to, the clamping, there's a fair bit of clamping force in order to keep everything tight. Because you don't want any gaps. You want it to be tight, okay? That's why they're using so many clamps. Because all you need is, like if you have clamps every 4 inches, I guarantee you're gonna get a gap. Okay? And it doesn't have to be much. Then it's a pain in the butt. So now we're getting into the back. So once you've got the back, the sides, the back plates put together, and you can see, I don't know if you can see it from where you are, but he's actually drawn the sides, okay?
Yeah.
And then this, it's mahogany, I think, but it is quarter sawn mahogany, like really good quarter sawn mahogany, that he's taken a slice off the end of the board, okay? So that you got the grain going this way, and then you glue that along the joint to reinforce the joint. So you don't want that joint pumping apart.
Some manufacturers will have like binding material between the two booknet parts?
You can,
So like the Martin herringbone guitar.
Yeah,
as
you
it's
can.
referred
you can.
to. Now, that additional mahogany strip, I would assume, provides reinforcement when the glue joint of the two halves of the back and the binding material, that's a riskier joint,
Yeah,
shall we say?
yeah. And it depends on, like, if you're using purfling
Yeah.
in that joint or whatever you're using, right? So, but the guitars we were building, sometimes he puts that in his guitars, but mostly not. He just uses the natural wood jointed together because it's quite pretty, you know?
So how long in the 5 weeks are you now doing this part?
That's probably towards the end of the first week, okay? It's a fair bit of work.
Now, sorry, just to interrupt a moment, you were saying you're going to be building some more guitars
Yeah,
yourself for your daughters?
yeah.
Yeah. I'm looking, like, there's a lot of equipment here that's pretty specific and pretty, not inexpensive.
I'm gonna get to that.
Okay.
I'm gonna get to that.
Okay.
I'll give you-
Yeah.
I have,
Don't mean to rush you.
I have most of what I need. I have most of what I need to do this at home, okay? There's a few things I don't have, but if he trusts you in the shop, he has an alumni program where you can go down and use his shop for $20 a day. Yeah, but he better like you. Okay? And I get it. Like, this is his shop, this is his livelihood, okay? Like, if you're going in there and you're being a pain in the ass, well,
Oh, you're $20.
So that,
it's not worth the $20,
The
okay?
piece of mahogany strip that you just put on.
Yep.
Did that change the sound at all of the back?
Not appreciably. The next part you'll see. Don't get at me. So you see these guys here, okay? Those are spruce ribs or braces, okay? And they're quarter sawn. Did you find any? Shit.
Not my style.
It's all quarter sawn and dry, okay? And clear, okay? So basically you cut 4 pieces that are gonna fit as cross braces. Take a look inside any guitar, you're gonna see cross braces all in the back, okay? And that's really to stiffen up the back and to change how the sound happens, okay? The back is not quite as difficult as the top. The top is a little more touchy-feely. So basically, what a lot of people do is they would take those braces and they would go to a sanding dome, okay, and then sand them to the right shape, which is a pain in the ass, okay? What he does, again, like he's a very experienced woodworker, he built a jig. So one side of that jig, I think the next slide shows it. Yeah. So one side of the jig, this side here, has a 15-foot radius. Okay? The other side has a 30-foot radius. No, a 50-foot radius. So you use a 15-foot radius for the back, you use a 50-foot radius for the top. And by clamping those braces in that clamp, you just run through the jointer, and now you got a perfect fit every time. Okay? So, you see that board with the red around it? That's 15-foot radius. That is carved to a 15-foot radius. So that whole plate is now bent to that 15-foot radius. And you can see where there's the rib going down the middle. You actually chiseled out where the braces go. After you include it in, you just chisel the pieces out that you don't need. And then you glue those guys in. And then you use these springly things. Can anybody recognize these?
Fiberglass ones.
Yeah, where are they from?
Stanley.
Eh?
Stanley?
No. Close.
That
Think fencing.
Gardens.
You know the chain link fence? You know how when they grab the chain link fence and pull it in, those bars that they use? Guitar makers call them go bars, but if you buy a go bar from you know, any of the guitar supply places, they're extremely expensive, but you can go to Home Depot and get them for like $2 a piece. And you need a lot of them, a lot, okay? So that's just basically putting the ribs on the back.
Sorry, so this platform, sorry, you're saying it's a 15-foot radius, this one?
This one, yeah.
Yeah, so it's
It's dished
It's
15-foot
dished
radius.
15-foot radius. So you're pushing down that whole
Yeah,
flat
and those
surface.
braces are gonna hold it in that shape. Okay?
So is it the rib that's etched out or the centerpiece? You said they're.
The centerpiece the centerpiece, you just nip it out.
Okay.
Before we actually do this, actually skip the step. I mean, this is a 5-minute course, right? You actually run that back through the drum sander till you get to the right thickness, okay? What is the right thickness? Well, you kind of wait till Ted shows up, and he goes, well, where are you now? He says, well, about 1.8 mil. A little bit more. He says, just run it through a couple more times. And literally, you're adjusting it like that, right? Until you get it sort of close, and then he picks it up and goes like this. And what he's listening for is a waka, 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 okay? When you get the waka, 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 you know you got it. And he says, okay, stop, okay? But, you know, when you pick it up, if it's not thin enough, you shake it, you don't get any sound out of it, okay? So what he's listening for is that, okay? You do that for the top as well.
Is the dish in two directions or just?
It's dished like a lens,
Right,
okay?
okay.
A 15-foot radius in lens.
But it's not dished along the length.
Yes.
Well, it's dished this way. Is it also
It's
dished that
dished
way?
like a lens.
Like spherical. Okay.
Spherical.
Okay,
Okay.
okay, gotcha.
Like if you take, the way they make these things is you make a jig, you run your router down to the middle,
Yeah.
and you spin the pieces of wood underneath, and then that jig is actually set up with that curvature. So what
Right.
it is, it's just like a lens, okay?
Okay, got it.
Is there's no problem with the, like, along the length of it, because you put a rib there, there's no problem with getting it to follow the curvature?
That thing is maybe like a mil, a little bit more than a mil thick. It's very thin. So when you glue it in, I mean, you gotta be pretty careful, right?
Yeah.
But that's why some manufacturers chose to use fiberglass for the back and sides. Easy.
Yeah, but you gotta remember, okay? The back of a guitar is a sound creating element of the guitar, okay? It depends. If it's somebody who's gonna be standing playing the guitar, not so much. If it's a fingerstyle player where you're sitting, it actually makes a difference. So would I use fiberglass? No. Okay. Basically, there's no sound out of it. It's just whatever bounces off of it. So the next thing you gotta do is you gotta carve the ribs. And you can see here the way it's carved. So the first thing you do is you taper them, and then you taper them along the length, and then you taper them like this, and then you edge them out. So that it's kind of, you know what I mean? All along. And you use, actually they sell the planes here for doing that. They're expensive, but, and they're small. They're little, about this big.
And why is that?
Hmm?
Why are you doing that?
Why are you doing that?
Yeah.
I'll give you the engineering answer, okay? The stiffness of an element is a function of the cube of the height, okay? So by changing the height a little bit, or by you change the stiffness a lot.
Yeah.
By changing the width a little bit, you change it linearly, okay? So just over by experience, he's learned, or he's been taught, that to get a half decent sound for your back, you don't do a lot of sounding on the back, but the top's a different cat. On the back, you get pretty good results if you taper them, and then taper this way, and then taper it that way, and then taper them in, okay? He could do this in 20 minutes, done, okay? I don't know how long, it was like an hour, he'd be done the whole back, okay? Whereas for me, it was like a day, because you're like, oh, you know.
How do you know it's right?
It's not that critical.
Okay,
It's just not that critical. The top's a different count.
I will repeat that question shortly.
Yeah.
Dean, in my experiences, does it look pretty?
Yeah, that's part of it. But if you left it chunky, and like if you look at a production guitar, like I have a Taylor, okay, a production Taylor, and those pieces were all just cut on CNC. They actually stamped the back out, okay. So when you compare the sound of the Taylor to this thing, it's not the same. Okay, it's not comparable.
While the back is not, shall we say, pivotal to the entire sound,
It's important.
it's important, it has to have enough compliance for resonating the bass frequencies. The top is far more important
Yeah.
for the full frequency range,
Yeah.
but the back enhances
Yeah.
the bass.
And the super interesting thing about it, and I didn't understand this until I actually built a guitar, is you're not going to understand how that guitar is going to sound until you get the binding in.
Yes.
Okay? It's just, the binding is the stuff that goes around the edge, top and bottom, okay? Till you get that in, and like Ted said, well, you're not going to be able to tell. And he was dead on, like absolutely dead on. Because when you tap it, you can hear it. Right? So that's basically the back, pretty simple, okay? And then you got to glue it in. That was mine. That was before they were carved. Now this is the rig he actually came up with for doming the side, because the sides have to be domed to fit the back. Okay, it's got to have the right curvature. So that this thing here is a plate that's domed with sandpaper on it, and he's got this whole rig underneath it, an electric motor that spins that thing. So you don't have to sit there driving the bus. You just plunk the thing on top and just hold it in place, and until you chalk the edges until all those chalk lines are gone. So you know that your shape is right now. Okay? And then you go back to the go bar deck, and you get lots of go bars, and you glue back on. Okay? The only dimension that you've got is the center line. That's it. You have no other thing that's a reference on the guitar when you're building it. So when you're building, when you're doing the backs and sides, when you glue them together, you don't glue them flat like that. You glue them just a tiny little bit, maybe a millimeter, so that you get a little notch there. So you can find that center line again. Okay? Because everything is done to the center line of the guitar, everything. So when you put the back on, you line that center line of your back against the center line of your form. And that's how you get it dead on. The top. So first thing you do is you run it through a drum sander until you get the top, so that there's always a tiny little ledge there, and you can feel it with your fingers. You couldn't measure it. You can feel it with your fingers. So you run it through the drum sander until, and it's only the top that you do, until you get it just perfect, okay? You take it out, you go back to your drawing, you find out where the center of the sound hole is going to be, you put a 1/4 inch hole in there, and then that fits a 1/4 inch pin. And then, this is one of his jigs. It's brilliant. Everything was done in the shop. So there's a whole bunch of different holes, and they're all for different things, okay? But the important ones are these guys right here. This one, and that one, and this one. So this cuts the outside of your rosette, that cuts the inside of your rosette, and this cuts, just basically clears up what's between the two. Okay. So here's the rosette. So you run the router around, and that outside one basically gives you that line. The inside one gives you this line, and then the one in the middle, you put a bigger bit in, and you cut it the rest. What he was doing, I'm gonna get back to our guys who do 3D printing. So he was actually taking his router, putting it down on the corner of his top and just measuring, and then measure with calipers and stuff. And he would take him like 5 minutes to figure it out. So I'm watching this and, hang on. So I went home that night and I printed him out a jig that he could just stick on the bottom of his router, twiddle it down, and he got exactly 55 thousandths of an inch. Exactly. Okay. Came back the next day, oh, hey, that works great. Okay, there you go, it's yours. So 3D printing came in handy. Okay. So-
So this rosette, this is purchased, you made it?
I made it, everything.
You made it?
Okay.
Are you
The only
gonna
thing
tell
I
us how to make a
purchased,
rosette?
the only thing I purchased was the abalone. This part here. I mean, I didn't make the abalone. Obviously.
The
okay?
abalone made the apple.
The abalone made the abalone. Okay?
Yeah.
So this is, can anybody recognize that?
Is that spalted maple?
Spalted maple.
Maple.
Yeah. So it was actually a really crappy piece of spalted maple that I had to really work at to get to work properly. But the way you do it is you overcut the maple. There's actually a couple more pins on that router jig that make that maple a bit bigger than what it needs to be, okay? On both the inside and the outside. Then you take it and you haven't got the abalone in, okay? There's actually 7 pieces there, but you haven't got the abalone in yet. And all you want to do is glue that piece of maple in that's oversized. Then you go back to the router and you route out again the outside and the inside. So now you've got a perfect 1/8 inch gap, perfect, okay? And then what you do is you can actually see there's 3 pieces. There's what's called purfling, okay? Abalone, purfling, spalted maple, purfling, abalone, and purfling on the outside. Okay? So now when you got that done, now you can go back to the drum sander, and that is like literally that thick. It's thin, okay? So now you gotta be super careful. You run it through the drum sander until, when you rub your fingers, don't try and measure anything here, you rub your fingers across that. If you can't feel anything, you stop. Then you flip it over and you thickness it using the back, okay?
What kind of grit are you using on that? What kind of grit?
It was like 120 maybe.
Really?
Yeah, it's pretty rough. Yeah, and then basically, you go back to Ted, and he says, bring it down to 1.8, something like that. No, not ready yet. Not ready yet. Eventually, you shake it, and he goes, waka, waka, waka. Okay, now you're there. Okay, good. So now you've got the top basically thinned down to the proper thickness, okay? And guitar tops, I gotta tell you, are not thick, unless it's a really shitty guitar. Okay, a good guitar is very thin, because when you hit a chord, you hit any note on the guitar, you should feel that top vibrating.
What glue did you use on the abalone?
CA. Yeah, basically flooded with CA. You gotta be careful with those light colored woods. What you have to do is you have to shellac them first, okay, like crazy. Shellac them, and then you put your CA, because what'll happen is the CA glue will wick in the fibers, and it'll leave these black marks all around. So now your screw goes down.
Now I have no respect for people who make gypsy guitars because of the elongated oval sound holes. None of this round nonsense.
No.
That's easy.
I've actually seen heart-shaped ones
Yeah.
in Portugal. Amazing. Yeah, I mean, with a like literally to do this was no time at all. The way he's got it set up, it's pretty quick.
And again, presumably the hole shape affects the sound.
Yeah, well, it's the whole, not so much the shape, but the size.
Okay, so the surface area.
Yeah.
Okay, gotcha.
So you can see basically running through the drum sander, that's his drum sander by the way, running through the drum sander to get it to the right thickness, okay? Then, you take a piece of the You take a piece of the top that you cut off, because you see now the top is cut to the shape roughly. You take a piece of the top and you cut what he calls the Superman shield, which basically goes around the sound hole. So that's basically glued in place, but does not perfectly align with the grain. You actually turn it a tiny little bit, okay? Because now it's like plywood. And then using that hole right there, again, you go back, you re-drill your 1/4 inch hole, put it back on the router table, and then you use the router to actually cut the sound hole out, okay? But again, you throw lots of shellac on it to make sure that you're taking care of tear up, okay? And then you start sanding.
Now,
So
is
that-
there a reason, like you're saying, you slightly offset it so the grains cross-line it? Is there a reason you don't do it at 90 degrees?
Good. Said you don't need to.
Yeah.
It would be very obvious if you did that. And what
But
he
it's on
does.
the inside, isn't it?
No, you see the edge of it. You'll see it. You see the edge. Because when you look at the top of the guitar, when you look in, you'll see it.
Yeah. That looks like the kind of thing, like you know that, but.
Exactly. Yeah. Yeah. Now you notice this?
That's the time
Every
you
time
finished
you
it?
do a glue up, and he was really picky about this, you take a piece of tape, you write down the time, you stick it on it, so you know how long it's been drying. Every time. Okay. Some things, not a lot of stress on them, you can take them out in an hour. Other things, like when you put the bridge on, you leave it overnight, minimum. Now comes the fun part, and it gets better too, by the way. So, inside the guitar, there's a series of braces. You've got cross braces, okay? And you've got a whole series of tone braces and finger braces. So you can actually see here, all the braces are actually in place, but not carved yet. And look how many go bars are there, okay? And again, now that's on a 50-foot radius dish. Okay, so that is now radius 50 feet. You got to go back to that drum thing, and you got to sand to 50-foot radius.
How many of you were making guitars at the same time?
Including the instructor 6.
So how do you do the glue-ups and everything else?
We each have our own setup.
Your own setup, with your own go bars, your own dish.
Like he had enough probably to do at least 4 guitars at one time, but everybody's at a different stage, right? So,
That's why I charge $20 a day.
yeah,
And that's also why they put a piece of tape with the glue time.
that's right,
Yeah.
yeah, exactly.
Yeah.
Hey, you're over your time, yeah. When you're doing the tops and the backs, you have to be, you leave it a little bit longer, okay? Because you don't want that to move. So basically then what you do is you carve. So you can actually see how this was carved. See that, the way it's carved? This is a bridle joint. Right here, it's a bridle joint. So the top part of that bridle joint in one direction is going to be weak. That's why you put that brace across the top. And then you carve it down. So there was still carving that had to happen on that, but it was pretty close, okay?
That is awesome. I didn't notice that before. The shield that you made for the tone hole
Yeah.
lines up with the braces.
Yeah, exactly, yeah.
Wow.
Yeah,
And it looks like you pre-finished the dome as well.
it's, yeah, at the top, you
Yeah,
actually
based on the
finish.
color difference between.
Yeah,
the
you
arch
actually,
and-
you have to put shellac on the inside as well, because you don't want to have shellac on one side and no shellac on the other.
Mhm, true.
Okay, Mr. Guys, woodworkers guys, you know that's a bad thing to do.
Mhm. Do we care what kind of shellac, like blonde, amber, or?
This is blonde.
Yeah.
So, getting back to the sound, okay? I couldn't get, like, trying to record this was really difficult. Holding that piece here, you could actually hear it ringing, okay? And hitting different spots on the back, you're gonna get a different note, okay? On one side of the guitar, so the bottom part of the guitar, it's gonna ring at a higher note, then it's gonna ring at the top part of the guitar, so the bass part and the treble part. Right? Your high E string's down here, your low E string's up here. Okay? So if you're quiet, you might actually hear it. It's not the best, but whoop. It's hard to hear, but you can hear it is ringing. And then you dome the sides so that it's going to fit the top perfectly, okay? And it's got to fit perfect, okay? And then using a whole pile of go bars and cauls, because that wood is soft. It is really soft, okay? You basically glue the top on. And again, using your center line, reference point that you've marked, you know, that's the only thing you've got. And then you basically align those lines with the jig, okay?
So if you're using Type Bond 1,
Yep,
and you're trying to put all those go bars in,
yep,
you've got to have help to get it done.
did it myself. You
Really?
gotta go quick, yeah. Yeah. You have to
How
go
long
quick.
did it take you to glue that up then?
Like what you have to do is you have to prep everything. You have to have enough go bars. You have to count your go bars. You have to have you have enough calls. Everything's got to be set up. You can set up the calls ahead of time, and then the go bars just go in clink, 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 clink like that, very quick. So that probably took me 10 minutes to set that up. Lining it up.
But the preparation work took an hour.
The preparation work took me half an hour, right? Counting all the go bars and all that kind of stuff.
For those that do not like glue up, that's a nightmare.
Oh,
Yeah.
yeah.
That's
Oh,
a
100%.
nightmare.
100%.
What's the open time?
Hmm?
What's the open time?
The open time on this stuff, probably 10, 15 minutes. in there. So you gotta go quick, yeah.
So you were saying that depending where you tap the top, you're gonna get a different note. So you're gonna have a range of notes that you're gonna hear.
So what you want is you want that guitar to be responsive to the strings,
Yeah, so you've got a 3-octave range on a typical 6-string.
but it's gonna be vibrating in tons of different frequencies.
Yeah, so what range of frequencies do you need to cover to know that it's right?
Tap, tap, that sounds about right, that's how you do it. Because you're not gonna know until you have the top glued on
Yeah.
and the binding done. So a lot of it is experience. And that's why, when you look at like somebody like Linda Manzar, whose guitars start at $20,000, okay, and go up from there, okay? Her guitars sound amazing, like, okay?
And a fraction of that is, a tiny fraction of that is the materials.
Yeah.
The rest of it
Yeah.
is the labor
Yeah.
and the assessment.
Because I
And,
mean,
and because she's done 5,000 guitars.
yeah, I mean, in theory, you want the body to resonate at the entire range of frequencies that the instrument's capable of producing. Like, God help you if you were building a harp, you know, but, yeah.
People do it,
Yeah.
and they've been doing it long before they've had instrumentation to do it.
Yeah.
Are you
Okay?
doing?
And I actually talked to Gert Laskin. I don't know if you know Gert Laskin?
Grit Husband.
Eh?
Mr.
Gert, yeah, Gert Laskin,
Mr. Inlay.
Take a 5.
yes. Well, yeah. Yeah, I'm literally not even halfway through this.
Yeah, I know.
Tune in next time.
So, yeah, we'll take 5 minutes, but Gert Laskin, I talked to him, and I asked him, I said, do you use instruments? He said, nope. It says, it wouldn't tell you anything. He said, really, it's all your ear. And it's your experience after making 500 guitars, okay? That you know, a guitar that size, you need to trim it down here. That's why you have to work with a luthier. To try and do this kind of on your own hook, difficult. So I think someone would like to
But there's
take 5 minutes.
variations in wood and
So
species
5
too.
minutes, okay, because this guy's still got a long way to go.
Don, you've been talking all the time.
Hey?
You want some water or something?
No, I'm good.
You good?
That's good. Terrifying.
We'll start at 5.
Hey, where we left off?
Ta-da! We have the box done. No, it's not done yet. Now comes the scariest part. You think I'm... Anyway, you can see there's a different color around the edges. That's where I put shellac around the edges. Okay? Because you actually have to go to the router now. First thing you do is you route, well, you basically do a bit of sanding to get the glue schmoo off of it, okay, off the sides. Then you go around with a router and you get the rough shape of the top so that it matches the sides. So now you have that kind of thing, okay? But now you got a raw edge there. Well, that's not going to look very good, okay? Next thing you do is you put your end wedge in, okay? Basically, if you do a straight piece, it's like you gotta be dead on, okay? Because you can see there's purfling, bird's eye maple, purfling, and then, okay? But if you do a wedge, thinking way ahead, okay? You do a wedge, then all you gotta do is get it close, you push it in, and it wedges into place, you're done, okay? So that's the end wedge.
How hard do you hit the wedge?
Not hard at all. Just, it's literally finger tight, okay, that's it. And then you have to put some weight on top because you glued it, right? So you put a little weight on top of it just to hold it in place while the glue sets. And then there was Old Glorious sanding. I will spare you the pain, okay? You've got to sand the sides, the top, the back, sand and sand and sand. Fortunately, he has a really good sander that for the top and the back made it fairly easy. But you've got glue and all kinds of schmoo all over this thing at this point. But I'll spare you that.
So just as an indication, how much time is spent on sanding?
A day, easy.
Yeah.
Easy.
And then down to 400 grit, 200?
Down to 400, 320.
320.
Yeah, if you go to 400, if you go too fine, your finish isn't going to.
Yeah.
Right? So you have to be careful about that. This is the scariest part of the whole friggin' process, okay? And it's cutting the binding channels, and there's 2 of them.
Before you get into binding, what tool are you using for sanding? Is it a power tool or you're just by hand?
Well, the top and back, we use a power tool, okay? He used a Festool vacuum with it's a really, really high-end sanding.
Merca?
That's it,
Mm.
okay? And literally, and it's like 120, okay? And that's it. You just sand it to 120, maybe 220, that's it. Okay, no more, no finer than that.
No swirl marks? No swirl marks?
You go over it afterwards with in the grain, with the grain, okay? Very lightly, that's all you have to do. Now comes the really friggin' scary part, okay? You spent 2 solid weeks to get here, okay? Now you gotta take a router to it, okay? And the binding channel is actually 2. So you've got, if you look at the top of a guitar, you got the top of your guitar, you've got purfling, and then you got your binding, okay? And that purfling is about that thick, that wide. Your binding is this wide. So there's actually 2 channels there, okay? And the way he does that is he's got router bits with bearings, literally adjusting the bearings by thousandths of an inch. Okay, he's got a whole series of them depending on what he's doing. Anyway, so basically what you do, this is the sled you set up, and this is the rig that he actually uses for actually cutting the binding channels. And you can actually see underneath, it's not sitting on very much. There's the bearing, and you can just barely see the router bit there. You gotta be really careful, it's going the wrong direction with the grain,
Yeah.
okay? That's why you gotta stop and shift them.
John, the top and the bottom are not parallel, correct?
No, they're not.
No, this is the
And that, the router actually rides up and down.
Every time you stopped, I was wincing, because isn't that gonna burn?
It doesn't actually. And even if it does, you wouldn't see it. Because it's gonna be inside. You wouldn't see it. That was freaking scary, okay? I gotta tell you.
Yeah,
Like it was, am I going home now for the rest of the night? I'm going,
Done.
yep.
So you've laminated the sides, they're maybe 4 mils at most.
Oh, you less than
And then you've got no ribs on the sides.
that. Correct.
So the top's been glued flat.
Oh,
And
there
where
is,
they
there,
mate, you
there-
just
there
remove
is,
it.
there is a binding that goes inside that. I
Oh,
didn't,
okay.
I mean, I've only got an hour to go over 5 weeks, right? So there's actually a binding that goes inside. You actually bend that as well on that bending rig.
Okay.
And the binding, the outside binding is also bent on that rig. So everything that you need to bend is bent on that rig and is bent to that shape. So that when you put it in, it just goes.
So that binding's created a step to glue the top to the sides.
Correct. The purfling is very thin, so it's not a problem, okay? So the first thing you do is you put the purfling in and it's glued in with CA glue, okay? And then you put the binding in and it's taped in. We'll see what I mean.
Okay.
So, I think, there, you can see the purfling's in already. And then you put glue in, and then you start putting the binding in. And because that glue sets up quick, you're putting the binding in and then taping it in place, like with that stretchy tape. And you're taping it in place. You can only do like maybe 8 inches at a time, and then you put more glue in it, so you keep going around the guitar, right? At the neck end, you don't have to be quite so accurate. On the tail end, you got to be dead on the money, because you see it. It's right there, okay? This is how you put
Picture
the
sealed here.
binding on.
First, push with the thumb, stretch with the other hand, and put it down. Okay, so remember to keep pushing down, pushing in, and then tack it with the tip.
Now, he goes further because he's quick. He's really fast doing this. Like, he was going slow showing us, but I watched him, he was just,
You want to have one of these under your guitar, obviously. This is one of the harder parts of guitar making. It looks simple. You'll find out tomorrow,
your hands are.
or when it's dry, that it's not where you hoped.
So a couple of the guys had tiny little gaps, and basically what you have to do at that point is, you find it. I only had one tiny little gap, and basically you just take a big long clamp, you put some glue in, you stuff it in, and then you clamp it till that little opening closes, and just leave it, and then it's fine. So that was my guitar after I got it all taped up. I think I've used up all this tape.
it's actually pretty cool. You should have just left it like
It's
that.
kind of nice, isn't it? Yeah. So that's what the box looks like when you get it done. And after a bit of sanding, and there's a bit of finishing on it,
So now you know, now you can figure out what the sound is gonna be like?
Yeah. Now you tap it and go, oh shit, okay. And all the guys were sort of sitting around going, this is really cool, listen to this, come here, listen to this. So.
Did anyone have any dead duds?
Hmm?
Did anyone have any dead sounding duds?
No. No. Ted would not allow it. You know Ted.
Don,
Yeah.
when Mary and I came down and I went out into the hall where he has his guitars for sale. I could not believe, just talking like this, and the whole room was vibrating with
The guitars, yeah,
the guitar notes.
yeah, yeah.
Like
Yeah.
really alive.
It was actually interesting because, you know, as you're doing this kind of stuff, it's hard. It's like, it doesn't look that difficult to do, but it's very precise work, right? And sometimes you screw it up, oh, you know, you're sitting there like cursing at, you're kicking yourself in the butt. And then you just go in the front room and grab one of his guitars and you play for a while. And, okay, I'm ready to get back to work.
I can do this.
Yeah, okay. All right, I'm better now. So now you have a guitar body. The next big part's the neck. So how are you going to put the neck on the guitar? So the first thing you need to do is you need to cut a mortise in the body. And now you got to go at your body again with a friggin' router. Okay? And one thing I think you should notice here is some of his jigs are kind of chowdered up. So I talked to him, I said, Ted, I said, I do 3D printing. Like, give me the dimensions. I'll print you up all these jigs. And if your students chowder them up, just print another one, okay? So I've been working the last month or so doing jigs for him. So, and I just finished this one. So literally, I'll print a couple of tops for him, and as the students chowder them up, you just take that top, throw it out because it cost $1. Put a new top on it, and away you go again, right? I'll print him another one, so he's always got one spare.
So he likes, you can go in for $20 a day.
Yeah.
Yeah.
Yeah, no problem.
For free.
No. I mean, this is his business. Okay, so I get that. Okay. So basically, what you've got to do, the neck actually is a mortise and tenon joint. Okay, and it's very accurate. Okay. It kind of looks kind of raw at this point, but it's actually extremely accurate. Okay. So that's that end. Now comes the fun part, the neck.
So it's not a dovetail?
It's not a dovetail. You can do dovetail necks.
Because
Okay.
I mean, a dovetail is a mechanical joint. A mortise and tenon is sort of a mechanical joint, but it relies on glue to keep it together.
Nope.
Yeah, okay.
It's bolted. You want to be able to take the neck off the guitar.
Okay.
Is it glued with hide glue then as well? Or?
No, it's glued with Type Bond 1 actually.
Okay.
So yeah.
To that.
Yeah. But mostly what holds it in place with bolts. The net, the fretboard that goes over the top is actually glued to the top, and then you have your mortise and tenon with bolts that hold the whole thing in.
Oh.
You look at a lot of guitars are done that way. And there's many different, like some people actually use dovetails. Some people just actually have the thing sitting flat against with bolts and that's it. I'm not too keen on that, but anyway. The neck. So basically, as Ted says, you start with a chunk of wood and you take away everything that doesn't look like a neck. Okay? What you start with, you actually start with 1, 2, 3, 4, 5 pieces of wood. Okay? This is cherry. You have purfling. You have maple, purfling, and cherry. That's the start of the neck. This angle is about 15 degrees. And this is just basically rough cut to the shape. Okay?
And that's joining the body at what fret?
So it joins the body at the 12th fret. 14th fret on my guitar. So that's a 25.5-inch scale.
Yeah.
Okay. You can do them at 12th fret joint. Okay, which makes your fretting at the for the low end a little bit closer. It's still a 25.5-inch scale. So, it depends on how far up you want to work on the fretboard. So that's the neck blank. That's what you start with, and you can see right at the very end, which you have to cut off. That's going to be the tenon at that end. So the first thing you need to do is you need to cut 3 slots in the neck. You use a table saw to cut 2 slots on either side of the center line, and you use a router to cut right down the center line here, for the truss rod. That truss rod allows you to change the camber of the neck. Okay. Remember, as you tension the strings up, it's going to cause the neck to do this. Okay. So you want that neck flat. So that truss rod allows you to do that. These guys here, those 2 rods there, are carbon fiber that actually stiffens your neck up. Okay. So that it's not going to creep on you. And according to Ted, he's been making guitars for years now, and he's never had to redo a neck, reset a neck, ever. So, but you can see on the headstock, I think that's Ted's guitar. You can see on the headstock, you've got a very thin veneer, and then you've got another veneer on top of that. You take that and you run it through the table saw to get exactly square, and that's where the nut's going to fit against. Okay? So that dimension is dead on. So what he's doing here, actually there, he's actually gluing the top piece on, the top veneer on, and then he actually rough cuts the underside, and it's hard to see here, but he's got a jig that fits underneath his belt sander, okay? And then he takes the neck, turns it upside down, and the belt sander is actually running this way, okay? So he actually takes the belt, he actually takes the neck, and you basically put, and you set that wedge up so that you get the exact dimension. And it's all done very, very fine adjustments with his hammer, the framing hammer, okay? Till you get it exactly the way you want it. And you just take the neck and you slide it on this piece of wood here, in underneath, and it gives you exactly the shape of the headstock. Perfect. Right there, see? And then you take a piece of whatever veneer you're going to use for the back side of your headstock. You bend it on a hot iron to get the right shape, and then you use a special caul that actually fits exactly to the shape of his drum sander, or of his belt sander, okay? And then you literally hammer it in place so that you bend the wood so that it fits perfect, okay? And then you end up with, basically with the neck, the headstock roughed out, the right thickness with the veneers on both sides. So you basically have a veneer like a purfling, the neck material, the purfling, and then it's not purfling, it's actually very, very thin veneer. And then a thicker veneer to give you the exact thickness that you need for your tuning machines. Now you have to connect the neck to the body. You don't just stick the sucker on, okay? It's got to be, the angles and stuff have to be right too.
The neck at this point is different. So I'll sometimes take a look at mine, I'll just put a piece of wood, and I'll back up, and I'm pretty happy with that. It's a bit higher on the right. Okay? But this is one of those things that's just sort of the result of a whole bunch of processes brought me to this point. See, if you stand back there, I think you'll see, that looks like a blowing. See that? See what's happening?
You see what he's doing there? I'm going to stop it right here for a second. So, again, it's a jig, right? So he's measuring from where the bridge is going to be, and he's got a little spacer there for the bridge. He's got another spacer at the edge of the body, and he's got another spacer at the end to know where the neck is supposed to be. Okay. So when he puts it on this particular guy, he put it on, and he knew that he had to tilt the neck a little tiny bit. Okay. So when he cut the tenon, he took that into consideration. He actually cut the end off of the blank with the bandsaw, and then he knew the angle he had to make. He set that up on a jig on the belt sander, and then just sanded it so that it was dead on. Like, you can be off, literally it's about, angle-wise, it's about 1.5 degrees. Okay, that's all it is, it's not much.
Neck at this point is different. So I'll sometimes take a look at it.
So this is how you cut the tendon. Again, these jigs were a little bit chowdered up, so I just printed them some new ones. So basically, this plate here, that plate there, is pivoting, and he's got the top now at the right angle, okay, based on those measurements he took off of his guitar. So he sets that top so that's flat, then adjusts that back plate so that it's exactly the right angle, and now he's ready to cut his tendon. So basically now you could actually stick the neck on the body of the guitar. It's gonna look kind of weird because there's no fretboard on it, okay? But you can do that, okay? And you can actually measure now to see how far you are out. You're not gonna be perfect, but there's adjustments you're gonna make as you go along to get perfect, okay? The fretboard. My fretboard, I believe, is rosewood, okay? And his jig, super simple. That's the jig for cutting the fretboard. You take the fretboard out, he buys them the right thickness, and you put it on the jig, and you go, now your fretboard's done. Okay, but now you have to cut the frets. And everybody think, oh, cut the frets. He's got a jig that is so simple, okay? It took him a while to make it, but it's extremely simple. There's the fretboard actually cut with the fret slots in it. But you see, this thing here, there's actually notches. I don't know if you can see them, but there's notches and a little tiny nail, okay? That's in his, basically it's a sled, okay? So you basically tape the jig to the top of your how to be the underside of your fretboard, okay? Lining up the edge perfectly, okay? And you use 2 pieces of tape, okay? And so it's that really heavy outdoor carpet tape. Don't use the indoor stuff, you gotta use the outdoor stuff, okay? So basically you set that up, and you literally, he's got a blade, it's about yay big, and it's very thin. It's made specifically for this. It's for cutting frets. That's all it ever does, okay? And it's a tiny little old, like home table saw, okay? That we were using for storage. We're putting our shit on it. And take all that stuff out, put a sled on it. And literally, you run it, he said, you run it through, you don't come back. You go once, that's it. Then you pick your piece up, pull your sled back, put it back down again to the next one, and you count 1, 2, up to 19. And you cut each slot. So as you put it down, the jig fits into that little notch, and you cut. To do all the frets, it took me 10 minutes max.
Is the fretboard flat or is it radius?
It will be radiused. It's radiused to 14 inches, but right now it's flat. Okay? Because if it was radius before you tried to cut it, it's hard. Because now you're dealing with something that's flopping around. You radius it afterwards. You overcut the knot. So this is actually putting the fretboard onto the neck. He's got the nut in place. It's not carved yet, but it's in place.
Okay, so then I want to center this thing. So I usually eyeball it and then I measure it in millimeters. So at first, 14, okay, so just scooch it over a bit. too fat, and then up here I've got 11, 12, 11 and a half, 11 and a half, damn near 15 scribbles or whatever. So now, to keep this lined up, sorry if I'm moving the water in the middle, we're going to put these little pieces of wood because without them, you know by now that lots of glue leads to swimming parts, right?
Mm-hmm.
So I use these type of clamps with they're kind of a bite to them on the front. I find that pretty good. So we put on a little bit of wood on either side.
So you notice the fretboards are binding on them? So you don't actually see the tang from the fret.
Okay.
It's bound.
So that's right where I want it. And you want, when you're setting up, this shouldn't fall.
Fine adjustment.
I don't care side to side. I only care about thickness.
So that's how you basically line up the fretboard on the neck. So this is rough cutting the fretboard.
Now the guys say, I'm like,
That's actually my neck. I wanted to get a video of it, so that's you guys get the idea. This is actually carving line.
now that I take the material off, that line is really too wide. Then coming down from there, kind of like that.
See what I mean by doing stuff by eye?
Some kind of,
I mean, it's really, if you want a pleasing shape, right? So whether it's millimeter.
kind of like that. As we are shaping, how the heck do you get it to the right shape? So I've got these three things, and those are gonna go here, and they go down to the fretboard. I've had the fancier ones, but I'm pretty happy with this one. So you're gonna go like so, no? It's tearing a little bit. Spoke shapes can be used on the pull or the push stroke. You just put your thumbs in there and your fingers there. It's actually cutting a little bit better. Okay, so you don't have to swing a lot there, right? So you just kick some ass and then put this on, you go, oh, not good. And you say it with that accent. Not good. Not good. Pick up. Oh.
When you hit the midpoint, when you hit the midpoint on the set, are you thinking about where the fret is, or?
But you get the idea.
Yep.
so in terms of that, I'll actually knock those off.
But you get the idea about it. So that's my neck. After it's more or less cut, still a bit of work to be done on it. But that, probably day and a half. And he could do it in an hour. Like, so, think of an aircraft. You got pitch, yaw, and roll. Roll's not so much of an issue because it's going to be set up when you glue that fretboard down to the top. But it's the pitch and the yaw. Okay, yaw is this way, pitch is this way. Okay? And the way you deal with that is you measure along the edge of your jet. Like you could do it on the center line if you want, or you could do it just with a straight edge, and then measure your offset from your center line. You know where your center line is? You measure your offset from your center line, and it should be exactly the same. So now you've got the yaw fixed. Now you got to fix the pitch. Okay? And the way you do that, I don't think I have a picture of that, but no, I don't. The way you do that is when you cut the tenon, so you got the tenon sticking up like this, and you got the shoulders, you undercut and you leave maybe 2 millimeters in the edge, and then you set that on the top and you measure with that device, remember? Okay? That measures how far the neck should be back. And you basically, it's called flossing. You take a piece of sandpaper, you put the neck on, you hold it exactly, and you pull the sandpaper out exactly straight. If you pull up this way, you're gonna nick the edges off. You pull down this way, you're gonna damage the edge of your guitar. Pull it straight out. And you keep doing that until, you can do one side to actually shift it over to get it to line up perfectly. And by doing one edge, like the bottom more than the top, you'll get it to tilt one way, going up, and you can get it to tilt the other way. So it takes hours, like literally hours to do this. But it comes out after I did it in I was lucky, I did it in about 2 hours. I got it to within like really close. And you can see the holes have already been drilled for the two machines. So we're getting close. So the neck is now glued on. So basically, it's clamped. So basically, the fretboard where it goes past the neck is actually glued onto the top of the guitar. So you actually have to remove any of the finish that you put on there and glue that down. And then there's a bit of glue put on those little tiny edges. And then you've got bolts that come through that actually hold the neck in place. That's it. Yep.
But this is why I asked earlier about what fret you joined the neck to the
14.
body, because that has implications for where the bridge is.
Yep.
And the angle that the neck
Yep.
has to be
Yep.
at, and also the bracing inside as well.
Yep, 100%. 100%, yep. But the bracing inside, it is what it is, right? Like there's a whole process to get there, as Ted says. So, whether you're going to be millimeter here or a quarter millimeter there, okay?
But where it is. Okay?
Yeah, exactly.
I mean, if you're extending the fretboard another 2 inches into the body,
Yeah,
okay,
that's right. You're going to have fewer frets on a 12 fret than you do on a 14.
yeah.
So often with a 14 fret, you do a cutaway, so you can actually gap.
Yeah.
But that's a whole different cat. That's the next course. So the bridge, you start with a piece of, again, I think this is rosewood, and he's got it all set up with jigs, so you can't screw it up. I managed to screw it up, but that's okay. I admit to them. But, and it was the dumbest thing anyway. So the first thing you got to do is you kind of cut the slot for the saddle, okay? And the saddle is just a piece of plastic or bone, okay? That is, like, it's not shaped at all yet, okay? And it's a specific length, okay? And you actually have to cut it down to probably millimeter or 2 millimeters up above the bottom. So it's got to be pretty deep, okay? And then you basically drill the holes for the pegs, and then you basically chamfer the holes, and this is where I screwed it up. I was chamfering the holes, and it slipped a little bit, and the chamfer went down and put a dent in the top. I had to go right back and start redo the whole thing again. But I managed to do it pretty quickly, so it wasn't too bad. The other thing you have to do is you have to actually shape the end of the fretboard before you glue it on. To whatever shape you want. Sometimes you want to smile, sometimes you want to frown, sometimes you want some kind of weird thing, whatever, okay?
And the piece of green tape has your, when you glued it on the
Yeah,
clamp?
yeah, that's it.
Okay.
Yeah. So those clamps, there's actually a caul underneath, okay, that actually protects the inside of your guitar, and then you basically just clamp it down and leave it literally overnight.
How'd you get the call in there?
Yeah.
Never mind.
Yeah. Well, how do you get it out? Actually, one of the guys had trouble getting his out. He had to really work at it to get it out. So finishing. A lot of guitars you buy in the shop, they're all spray finished. And the finish is kind of thick, and it actually deadens the sound of the guitar. This is French polished. And it took literally days to French polish this. And I could probably use another 50 coats, but I haven't. But he gave a whole series of lectures on French polish. Final touches. Radiusing that fretboard. It's done with sanding. He does it by sanding it. So the sanding, you can see them over here. That's actually a 14-inch radius. Okay, and you use that for actually radiusing the frets when you put the frets in.
That's a Stumac tool?
Hmm?
That's a Stumac?
Yeah, that's Sumac, yeah. Stumac. Putting the frets in, what you do is because the fretboard is actually bound, so it's got binding on each side, so you actually have to nip off the tangs and fit them in, and then tap them in with a tiny bit of CA glue, and that's it, that's all you have to do. You have to cut them each individual, and then snip them off, and then there's a whole process to finishing them. That's a whole different cap.
So they have to be bent to follow the
They are
shape of
bent.
the-
In fact, he's got a special rig for bending. It's like a wire that comes out, so it's a straight wire, and you basically run it through this thing, and it bends the wire, so it's at the 14-inch radius. When you cut them, it's at the right radius. So that's it. So you're almost ready for the strings. Final finish and polish the frets. Carve the final nut, okay, which is a whole process in itself. Carve and final install the saddle. The saddle is actually interesting because it's actually filed on an angle from the 6th string to the 4th string. Then it goes back at the 5th string, and then back again at the 6th string. And you have to file it.
And why is that?
It has to do with the intonation.
Ah, of course.
And the fact that the slot is not squared, again, is because of the intonation. Best sign ever.
I gotta say, I do like the Eric Clapton touch of building the guitar on a carpet.
Oh, you have to.
Yeah.
Otherwise, you scratch the hell out of it.
Oh, it's just when I saw Clapton playing live, he plays on a, I don't know how big it is, 40-foot by 40-foot Indian carpet.
Yeah.
No,
Yeah,
I
let's
did
see.
Detroit, same thing.
Yeah.
It's kind of fun.
There it is.
Nice. Wow.
But the best part is the sound. Wow. Listen to the sustain. The other thing is, Roger, put your finger right there. Just barely touch it.
Ooh.
You feel it?
Yeah. It's beautiful.
Cool, eh?
It's gorgeous.
And then
Long decay.
feel it, just it's just,
So is that $7,000 now?
eh?
To sell it for $7,000 now?
Yeah.
That's lovely. Way to go,
Your
Don.
French
Nicely
polish yours,
done.
what did the others do?
They're all French bolts,
And where is the bolt that holds your neck on?
inside.
Oh, you just screw the things.
Yeah, there's two bolts here. And then this is glued down. There's a few boo-boos in it, but I know where they are.
And you're not
Did you say
saying.
what
I'm not
the-
saying.
Did you say what wood the top was?
The top is terrified Sitka.
How many rings to the inch?
Count them.
What was it so scared of?
It's torrified, not terrified.
Oh,
I don't know how they actually do torrification. It's done, it's a heat process.
yeah.
But I'm not sure exactly how they do it.
Kind of gives it that
Basically
age,
roasting
it's
it,
aging, some sort of aging process, right?
Yeah, but it's,
There's a really interesting video on
And-
Logs End where they explain doing that.
like it's a drum, right?
Geez, yeah.
That's why it works. Plays beautiful. It actually plays better than my piano.
Don, did you find that the Sitka in this was more brittle than usual?
Not really.
Because torrified maple is really brittle.
Yeah, it's not really. I mean, you're not really dealing with brittleness. You're dealing more with the softness of it. That's why you always have to have a carpet underneath these things. It's just like, yeah. Anyway. Yeah, super. Like even like the neck. It's a three-piece neck. And the way he does the necks was actually interesting. A lot of people use quarter sawn for the neck. But the problem with quarter sawn for the neck is when they usually do a scarf joint. And when you do quarter sawn, that's a weak spot. Okay, and you actually often see these things broken right here. Okay? Some the guitar drops or whatever, and it just snaps in half. What he uses is the opposite of quarter sawn. So the grain's actually running this way, which is the strong direction. And he actually cuts, this is all one piece. So it's, yeah. There you go.
Thank you, Don.
Yeah.
Thanks very much. We have one more. Tom.